Here we have a question. In this question, we have to find the displacement of an oscillating object as a function of time is given to us, and we have to find the frequency of the object, amplitude of the object, the time period of the object, and also find the angular frequency of the motion. So here, as we can see, in order to complete one cycle, or we can say in order to complete one complete oscillation, it requires 16 seconds of time. So here, as we know, first of all, let's understand what is frequency. Frequency is number of oscillations done per second. Means we can say, let's take one oscillation divided by the total time it requires to complete the one complete oscillation. That would be our time period, which is 60 seconds, 16 seconds. So from here, we can calculate the frequency as 1 divided by t. Now let's understand what is amplitude. Amplitude is the displacement of particle from its mean position while it is making an oscillation. So the maximum displacement is equal to the value of amplitude. So from here we can see that this is the maximum displacement from the mean position. So from here we can calculate the amplitude. Now, as we discussed, time period is the time required in order to complete one oscillation, that is 16 seconds. We can see the figure and calculate it. And the angular frequency of motion can be calculated as total angular displacement, which is 2 pi divided by the total time required, or we can write it as 2 pi f also. So from here, we will calculate the frequency, where we have discussed that the total time taken in one oscillation is 16 seconds. So we can write one oscillation divided by the total time taken, which is equal to the frequency of this object. That comes out to be 0.0625 hertz. Here we can write seconds to the power minus 1 as hertz. So from here we can write the frequency of oscillation is given to us, which is 0.0625 hertz. Now let's move forward. Here we have to calculate the amplitude. So as we discussed, the maximum displacement of particle from its mean position is called as amplitude. So here, as we can see, the maximum displacement is 10 centimeter here, or we can say that from the mean position, this is the mean position, which is the reference line at x equal to 0, or we can say this is the amplitude. On both sides, the amplitude is same, which is equal to 10 centimeter. Now let's move forward. Here we have to calculate the period of oscillation. So here, as we can see, in order to complete one complete oscillation, the time required is 16 seconds. As you can see here, it required total time of 16 seconds. So from here we can say that the time period of oscillation is equal to 16 seconds. So now let's move forward. Here we have to calculate the angular frequency of oscillation. So here, as we discussed, first of all we will calculate the total angular displacement while completing one oscillation. Let's compare it with the circular motion. So the total angular displacement is equal to 2 pi divided by the time it took to complete one total angular displacement. So from here we can write it as 2 pi divided by t, or we can write 1 by t as frequency f. So from here we can write it as omega equal to 2 pi into f. So as we substitute the values, we can calculate the value of omega, which comes out to be 0.393 radians per second. Therefore, the angular frequency of oscillation of the object is 0.393 radians per second. Thank you.